What's up, world? George at Olympia Steel. Can you make a steel building a house? Why not? They're doing it every day. What we're going to do today is take this plan that a lady had sent me, and we're going to design a steel building for this layout. If we scroll down here, you can see exactly what they're doing. Like, this is just a plan, though, so the inside you can design it however you want as far as laying the rooms out, where the bathroom goes, where the bedrooms are. But the overhang's pretty dope. One thing we're going to do on this one is we're going to get rid of these doors. We're going to move them over here. So we're basically, she wants to have this plan similar, but take 10 feet off the overall garage length and move these doors to the end wall just to shorten up the footprint. So only thing I noticed is the roof pitch is pretty steep, but you can see the inside's laid out pretty dope. I want to lay on the couch. That might make me something at that table there. Thought I saw Ricky Bobby, but it's the Flash or the Daredevil. I don't know. Pretty nice layout though. It's all wide open. I like the cathedral ceilings. Got the guitar, so serenade his chick. Whatever you do, jamming out in the bedroom. So here's an overall, it's like a bird's eye layout. You got the dining room, the bedrooms, the garage, little truck. So we're getting rid of these doors on this side and we're going to move them to the back. So there's going to be 3 doors over here. Here's the layout. I actually recorded this video previously, but my mic wasn't on, so that was a real dumb move. So hopefully this is recording and this video will get published because the barndominiums with steel buildings are very popular. I actually like to do it myself, and I have plans, but just got to get that money together to make it happen. So maybe I could help you make this happen. What we're looking at here is a 39 feet. But what we're going to do is 90 feet because we're going to drop a couple feet off of the garage. But you can basically see we've got a bedroom laid out, bedroom, little office up in here on the other side of the bathroom. So that way when you're on your conference call and somebody's dropping a deuce, I'm just playing, man. But anyways, that might not work for me, The master bedroom, I'm just being funny. The dining room and the great room with the round table. So let's get into it. I named this Barndo 79 or 72923. That way, if you see this video and you want it designed for your location, because they're engineered buildings, so at the end of the day, you're going to get 3 sets of engineered stamped drawings with the most recent building codes, the snow load, the wind load. We typically do a wind exposure C, which I could get into later. You're going to have those drawings to pull your permits. So it's going to be designed for your specific location, and it's going to be stamped by an engineer for your location. So it's engineered for where it's being built. That's what's nice about these buildings. And I'm not getting into any prices. I'm just showing you what we could do because the prices vary. I mean, if you're up north and you got a high snow load, these overhangs really are going to cost you a lot of money simply because they have to be rated for twice the roof snow load. Also, if they're like 2 feet below the eave, you got to account for what's called snow drift, and that's the snow blowing off the top of the existing building onto the overhangs. If you're down south, wind's an issue, so the wind may create the extension beams that I'm going to use for these overhangs, little patio area. It's going to make that steel be a little thicker because it's got to support the wind coming up underneath trying to blow it off. I mean, here in Pennsylvania, we've got pretty moderate snow, 25, 20-pound snow load, 90-mile-per-hour wind load. The most recent building code would be 115 mile per hour. But honestly, I'd recommend that you buy in Olympia Steel Buildings, because we manufacture quality buildings and we keep you up to date as far as the codes. A lot of other companies will just give you skimpy codes, B exposure, lighten the building up, not even put a collateral load on it, just to give you the best price. And at the end of the day, I mean, if you're going to be living in it, you should pay attention to the codes. So let's get into this. We're going to create a job. I already did. I titled it 72923, like I previously said. That way, if you see this video and you're like, hey man, I like that design, I got some property that it would fit on, you know, maybe I don't want my office next to my bathroom, but maybe I do. We can make it happen. You can lay the inside of the building out however you want. We're just going to do the outside shell because that's what we're selling you. It's a bolt together kit. We'll manufacture it, ship it out, you bolt it together. So we're going to go 39 on the width. We're going 90 on the length. So 39 here, 90 here. Just going to override this. It's trying to tell me what base spacing to use. So the E height, that's going to be the top of the sidewall. I'm not going to scroll pictures, but I'll show you. We're going to go, I previously did a 14 foot, so I'm just going to stick with that to keep things simple. And then our peak offset is going to be half. If you want the peak right in the middle, it would be half of this 39. You could offset it to one side or the other, but you know, if you didn't want a symmetrical gable. Sorry, I heard something outside, kind of caught my attention. So let's do the math. 19.5 is going to be the center. You can see how I moved this line over to the center. That's the peak of the building. We ran with a 612 roof pitch previously, which I thought was going to be it, but honestly, when I looked at the picture, it didn't look like it was enough slope. It's just with the steel, when you go a higher pitch, you're just making these rafters longer, which is ultimately increasing your cost, just because you're paying for more steel. So we're going to override the base spacing. Now in this building, I'm going to actually go back here to the first picture. So what they're doing here, the second picture, excuse me, they got windows pretty much covering this wall. And typically with a steel building, you have bays, which is our base spacing. With a basic steel building, and probably one of the competitors are going to sell you, is you have to put bracing in one of the bays, because it's not an I-beam at the end of the building. It's called a post and beam end wall, and it's C channel. It's a C channel end wall. Therefore, it's used because it's the most cost-effective way of doing the steel building. Now, the reason they do that is to keep the cost low. But if you want to have a big opening across that whole, like a hangar door, you would need an I-beam in the end wall. If you wanted to put a bunch of windows in, you know, like in this case, we can't have rod bracing going through the windows. It's going to mess up their view. So what I'm going to do is just put a full load rigid frame in the end wall. But typically, you got to have one of these bays, which I'm going to do right now. Let me bust out my calculator. 39 divided by 3, 13 feet. It's pretty basic. Can't believe I needed to bust out my calculator. But see how we're splitting this up into 3 bays. So this is going to be a C channel end wall. Typically, it's called post and beam. And then you would have a C here and a C here, which is an end wall column. If you want to do what everybody else does, they're going to have to brace one of these bays with a cross bracing, like a cable bracing or a rod bracing. Man, some shyster might even actually try to sell you torsional bracing, knowing that you're going to put all these windows in it. And a torsional bracing is actually using the girts and the sheeting as the bracing for that wall. So if you buy it and they tell you, well, you just put those windows in there yourself, and they've got it engineered with torsional bracing, you're basically getting rid of the torsional bracing when you put all these windows in. Does that make sense? So it's just something to keep in mind when you're looking for a building. So I'm going to go on the opposite end, and basically this is the far end, the right end wall, which is where we're going to put the garage doors. openings. We don't make doors, just the openings. Now this is our base spacing. When you design a steel building, the main supports, which are tapered columns, we can do constant columns, which are like a straight column, but it's typically a tapered column. You don't want to span no more than 30 feet. Otherwise, you got to get an engineer involved. I mean, it's possible, but it's just going to make the beams bigger because it's going to have to support 30 plus feet between the beams, which purlins go in the roof, girts on the sidewall. So in this case, if we go back to the plan, we don't really want a beam in the middle of the bedroom. I mean, it might be beneficial to some. I was giggling about it yesterday, but I don't know if you want a beam running through the middle of your bedroom there. So we're going to basically stagger these the bay spacing, which is where the main columns are going to be located, to kind of fall into these lines where the walls are going to be inside of the building. So we would have a main column here. We're going to do a full load rigid frame on the end wall. So we're going to have a column here. We're going to have one here. I think I dropped one. I split it up into 20 feet. So we're going to have a column somewhere in here. And then we're going to have the garage. And I'm actually doing a full load rigid frame on that back end wall, the right end wall too, because of the door openings. So if we go back here, I'm just doing one. Pretty sure I did one at 25. Let me just double check. Two at 20. And one at 25. Yeah, that's what we did. So this is going to be the garage area. The bedroom is going to be somewhere in here. Maybe between here. I don't know. We may have a column in there, but that's what I ran with yesterday because the measurements are kind of tricky here to add up. So we're going to go to the rigid frames. I got to go back here to the, we're going to make this, instead of a post and beam end wall, we're going to make it a solid I-beam. Therefore, we don't have to have any rod bracing that would intrude on the window openings or the overhead door openings. All right, so we did that. Now what I got to do is the base spacing also determines the size of the column. So like these ones on the end, they're not going to be as big as the intermediary ones. You can see the load width's a little bit bigger. It's calculated by the amount of distance on this side and the amount of distance on this side that the frame has to carry. That's what determines the size. I could probably actually skimp these two up a little bit and make this one the stronger one just because or actually skimp this one up and these ones would be a little bit bigger simply because this one's not carrying, it's only carrying 20 feet on either side, whereas this one's carrying 25 foot. So I could actually show you what I'm talking about since we're in here. I'm just basically going to copy this. So we're going to make frame line 3. What I'll do is just throw in a 1 and then the program will default and tell me, all right, so it's got to be 20 foot or 20. So now we're going to go back to this one and break. We're going to get rid of the middle line because we already created that. Let's see if the load changes on this. No, it's 21,967. Yeah, so I mean we picked up a little bit here. It's not like it's designed how it's supposed to be designed, so it's not really I don't know how to, it's not making the building any weaker, it's just being cost effective to an extent. All right, so we got to put some bracing in here, what I talked about earlier, the wind framing. You got panel shear, which is like a torsional bracing where the girts and the sheeting is acting as the bracing on the wall. There's a cable bracing and there's a rod bracing. There's also portal frames and wind vents on the sidewalls, which I'll get into here in a second. So in this end wall, like if we did the post and beam, we'd have to have one of these bays braced like that. That's not going to work with the windows we got. So we're what I did was made the end wall a solid rigid frame instead of a post and beam end wall. I'm sorry I'm being repetitive, but I'm trying to help you understand how this works. So we don't need any bracing on the end wall because the rigid frame is the bracing. Same thing on the right end wall. We did that because there's doors all the way across. I could do a rod to frame um, to keep the post and beam end wall. So basically what it would do is leave those bays open, but the bracing is going to carry from the rafter back to the previous rafter or the purlins. But in certain areas it doesn't work and it's not allowed. So I'm not going to get into that right now. At the end of the day, these people are living in it, so we want to give them something solid. So now on the sidewall, we got to have you got to have one bay for every 4 bays or one bay for every 100 feet braced. You could do a panel shear, but we do have some windows, and there's a walk door in the garage. Actually, since we're moving these doors to the back, there's nothing on the side of the garage as far as opening. So all we're going to do is I'm going to use a rod bracing, which is a cross bracing. We'll be at the YMCA. All right, rod bracing, and I'm going to put it in the garage, which is bay 4, looking at this end wall, or this side wall, which is our front side wall. I'm going to go to the, well, actually you need this in bay 1 because I'm on the back side wall right now, which is over here. So I'm going to brace this bay. Now I'm going to go to the wall that I thought I was on. I'm going to drop some rod framing in there, or rod bracing. We're going to put it in bay 4. So we've got both side walls and the end walls are braced. The end walls are braced with the rigid frame, and the side walls are braced with a rod bracing. And it's not going to affect where any of the openings are going. The roof, I'm just going to put it in bay 3 because it really doesn't matter. And I want to put it in the bay that's smaller than the bigger bays just to keep it a little cost effective. So let's start with the window openings. We got 6 of them. So in bay 1, we got a 9-foot wide window. I'm sorry. We're going to make it 3 foot off of the corner here, which is the offset. It's a 9-foot window. The header height's at 7 feet. Then the sill I was running at 2 feet. Now we're going to put the window above it. I'm just going to copy this because it gets to be a pain entering all that. So bay 1, we're going to make the header 13 feet. 10 feet on the sill. Because there's going to be an overhang right here. I'm going to bring the overhang in at 9 feet. All right, so we got that. Now we're going to, yeah. We're going to add the center window. Come on now. Oh, I forgot to specify that it's a window. So the computer was like, yo, bro, what is it? We're going to put this in bay 2. Same size. I'm going to center it. I'm going to copy this one. Come on now. I already did it. What was the issue with that? I think I know. I forgot to do it here as well. Out here looking like a rookie. Go ahead and fix this one before it throws up the flag. We're going to center it and make this one a little bit bigger. 1 foot actually. All right, now we're going to take this. Reach around the mic here. Take my offset to 1 foot. Copy this one. Paste it there. Bay 3. 1 foot. Oh, I copied the wrong one. So we'll just fix it. It's a 9-foot wide opening. The header height, which is the top of the window, is 7 feet. The sill height's 2 feet. All right, so that takes care of our windows on that wall. So let's move to this wall, which is the front side wall. So we walk around the right side of the building, it's the front side wall. Now, if I'm not mistaken, there's 1, 2, 3 windows. I'm pretty sure. I'm gonna run with this, but I'll check the picture here in a second. So we've got this main opening, looks to be like a 3, 6, 9 foot wide door. So we're gonna keep it 3 foot off the corner, simply because there's gonna be a column right here. We're gonna make this a 9 foot wide. We're gonna put a little extra room in there because it's a walk door. And that's a field located opening. So these windows, these walk doors that we're putting in here, all we're doing is supplying the jambs and the headers and the sill, and you would actually put those where you want them. We're not going to, when the building shows up, these window openings and this walk door opening is not going to be cut out. You have to actually locate it where you want it. The only openings that are going to be framed out by us would be the overhead door openings on the right end wall. Now we can frame the openings out for the windows and the walk doors, but you just have to be 100% certain that that's where you want them located. And that's like the main reason why we really don't want to frame them out, because something happens and the location of that opening needs moved. If we already cut it out, that's where it's going to be located, you know. So ideally, it's better to just get them as a field located opening, which is what we typically do. And then if you want to move it over 6 inches or a foot, then you have that capability and you're not stuck. So that covers that. We're basically just adding that walk door. That's why you'll see me getting a bunch of errors here. You see me putting, all right, it's the other one for the windows was at 3 because it's a window. And we'll do field located because we're not cutting it out, but we're going to supply the jambs, the header, and the cap trim, you know, like the trim package for it. All right, now I'm going to add a window. There's actually 3 of them. I got to check the plan for the location. Let me just do this real quick. 2 foot, 7 foot, 2 foot. These are like small windows that are going to be by the bedroom. So you'll see I did 3. It's a standard window. And the girt, the jam's going to run between the girt and the girt. So we're going to give you that vertical supply for the window. Now let me check the plan here, just to make sure I got the amount of windows. So we've got the walk door there. Here's a window, here's a window, here's a window. So we need 2 more windows the same size. And another thing, I'm not calculating, there's not enough data here for me to calculate the specific location of that window. So that's another reason why the field located window, like, hey, if you want to move the office away from the bathroom, you can, but you don't have any windows in there. But say you want to move the pantry and the bedroom, you can move the window too. You know, things happen, last minute things come up, and I'd rather you put the window where you want it than be upset that we already located it, because that's where you wanted it, but you changed your mind, you know? So we'll put 1 more opening in here for the window. And I'm actually going to move this one. All right, so we've got 3 windows. Let's move this one down a little bit too. Whoa, whoa. It's kind of a small window though, 2 feet. But you would think that you would want it big enough to climb out if you needed to, you know, in an emergency. All right, so that's cool. We've got the windows down this wall. Let's go back on this side. 1, 2, 3, 4, 5, 6. So we've got 4 small windows, a walk door, and a big window. And this is what we would call the back sidewall. So that's 6 openings. So we're going to start in bay 2 because it's bay, whatever wall you're looking at, you do it from left to right. So we're looking at the back sidewall. We'd be looking in on this way. Bay 1, bay 2, bay 3, bay 4. So 2, we're just going to come in a foot. We have to stay a foot off of this column for the framing, and then you got to stay 2.5 feet off the ends for your openings. So you can't just put a window opening in here at 0 feet because it's actually the center line of that column, the main support column. So that's why you have to stay a foot off. That way you have a little bit of room for your jams. Just some data for you. All right, so it's a 2-foot opening. We got a 7-foot header, 2-foot sill. It's a standard window. It's field located. We've got 3 more of those. So I'm just going to copy this, paste it, paste it, paste it. I'm actually going to, let's move this one. No, it looks like it's right there. So we'll just take this one to 11 feet. Keep this one at 1 in bay 1. Oh, sorry, in bay 3 at 1 feet. And then this one, bay 3 at 11 feet. Now we got to throw the walk door in there. And it looks pretty close to where where we're putting a support column. Now this is a walk door, standard walk door, and it's field located. So if you want to move it, you can move it. And then this big old window, I actually don't know what I did for the size of that. Oh, so it looks like 9 feet because it's 3 triples. 3 triples, what do you mean? They're probably 3 feet each, and there's 3 of them, so we're going 9 feet on that big window. If you're still with me, I hope you're learning something, and I appreciate it. Maybe you want to buy a building, you can call me. The number will be at the end. So it's a 9-foot wide opening. We're going to do a 2-foot sill because that's pretty standard with the rest of the windows. Bam. All right, so now we got to go to the right end wall and put those overhead door openings. These overhead door openings are going to be located and framed out by us, so you don't have to, you're not going to be able to move those. So you want to, again, make sure you got the specific location correct, so that way you don't have any issues when it's time to put it up. Shout out to coffee. So I got to be 2.5 feet away from that corner. It's a 9 wide opening, 10 tall. Now this is a overhead door frame layout. And we're going to remove the panel. Again, I'm going to copy this. Copy this. Just gonna move this to bay 3. It's a foot off of that end wall column. Might be 1.5 feet is what to make it symmetrical. There we go. And we're just gonna put this in bay 2 and center it. But this one's for her truck, her husband's truck, she said. So we got to make it 12 foot. I made sure it's not a camper or an RV because you would probably need 14 feet, you know? Definitely don't want to put an opening in there too short for what you're trying to put in the building. So we did all the openings. We're going to go to the loads because we got to add the overhangs. This particular one wants to go to the zip code 78114. This is probably the most vital piece of information in pricing your steel building because this is how all the loading data is calculated for how the building's designed. So now if you're in like Utah, there's case study areas where it depends on what elevation you are above sea level to determine what the accurate snow load is. You know, like it's not just easily published. A lot like Texas is pretty easily published with their snow loads, the wind loads. Pennsylvania is a little tricky as far as determining the county, what the county requires. And if you're in a snow load area, we got to really look at your elevation to make sure we engineer it with the appropriate snow load. And again, overhangs might not be your thing if you're in a high snow load area because they have to be engineered for double your roof snow load. So this is the building code. It's telling me that IBC 06 is okay, and this is what a competitor is probably going to give you a 17-year outdated building code. So I'm actually going to override that with IBC 21. We're going to bring it up to date. It's 2 years behind, but it's still better than 17 years. Or 7 years. I don't know what I'm talking about. 7 years. Got distracted. So this is pulling up Floresville, Texas, in the county of Wilson. And you're going to get engineered stamped drawings for this county, whatever it may be, depending on your zip code and your elevation. So it's saying we need a 5-pound ground snow load, the wind 111. I'm going to bump this up to 115 because it's pretty standard anywhere else with IBC 21. Unless you're on the coast. Just bump that up. And it's basically calculating the seismic coefficient for your location because we take into consideration wind, snow, seismic location, and wind exposure. So in this case, when you design a building, you have a ground snow load, which is what the county calls out for, and then you have a roof snow load. The roof snow load could be reduced based on this factor, the thermal coefficient. If you're heating and insulating the building, then obviously the snow is not going to sit up there like it would if it was unheated without insulation. So like if you plan on just buying a building and having a tractor sitting in it with no heat, you're just storing stuff in there to keep it out of the elements, then you should have it engineered with a 1.2 thermal factor, so the snow load's a little higher to consider, you know, to take into consideration that you're not heating and insulating the building. Also, though, this is going to get me way off track, but if you're just storing a tractor in it, you could do the engineering as an agricultural building, which lightens the actual loads on it and kind of saves you a couple bucks. We're not going to get into that. We're engineering this as a standard steel building so that you can live in it. We're going to take into consideration it's heated and insulated. They're going to tell me to reduce the load, the roof snow load by 70% because it's heated and insulated to 3.5, but I'm going to override it just because it's Texas and it's only 5 pounds and we've got a live load on the building over here, which is there for the people that are going to install, you know, to walk on the roof and install the panels and that's higher than our snow load. So reducing it really, it doesn't make any sense because we've already got this load, the live load is going to supersede the snow load in this situation. I hope that makes sense and I didn't confuse you. So most companies are going to give you a B exposure, which is basically saying that there's trees, there's houses surrounding where the building's going to be built that's going to stop the wind from hitting it at full force. As part of our Olympia brand, we do a C exposure. Unless you're on the coast. If you're on the coast, it should be D because you're on the coast. But anywhere else, we do a C exposure, which is engineering the building to be out in the middle of an open field, so it's fully engineered to withstand the full force of the wind with no obstructions preventing the wind from hitting it. And that's a nice. I mean, it's more expensive, but at the end of the day, you don't want to end up getting a B exposure and you're in the middle of an open field, and then we get one of these crazy storms, these 1 in 100 year storms, whatever they're talking about, and you're living in this building thinking you're cool, but the wind comes in corners and poof, starts blowing panels away. So don't be cheap on your house, your barn door here. And don't take me personal. I'm just being honest with you. You get what you pay for. Collateral load, we're going to put a 1 pound collateral load in here for half a pound for lights, half pound for insulation. And then you'll see this is what the seismic coefficient came out to be for here, this area in Texas. Last thing we're going to do is add these extensions. We're going to put a 1 foot overhang all the way around the building with soffit. And we're going to go with polar white. So I'm basically right now just adding 1 foot on each end of the roof just to give you some overhang. We could go 2, but honestly it's a pretty steep pitch, so I don't think much more than a foot would be necessary. If you want 2, we could do 2, but in this situation I'm just running with a 1 foot. So we've got that on the end. Now I need to go over here. Hold on now. What you talking about? Polar white. Shadow trim. We should be good now. So now I got to add an eave extension on this sidewall, an eave extension on this sidewall, and then we need the patio. So that's a total of 5 extensions. Let's do the front sidewall first. It's going to be an eave extension because all we're doing is continuing the roof line out on the sidewall. We had the gable extensions are different than the sidewall. We could just run the roof line, continue the roof line down, where you don't have that option on the end wall because typical steel buildings are just boxed out flush. So we're going to do bay 1 through 4. We're going to extend it out 1 foot on both sides to connect with the gable overhang that we put on there. That's just the extending out 1 foot here and 1 foot here. It's a 1 foot overhang. It's at the eave height of 14 feet. Now we got to do the beams, which are the extension beams. Just going to hot roll them constant. All I'm calling out here is the type of beam that's going to be used to extend the roof line out. And the purlins that the sheeting is going to attach to. This is your soffit. Underneath you get a soffit like you would any other overhang. I keep doing the box trim. And then we're going to copy the loads. Like I said, it's when you do an extension, it has to be twice what your roof snow load was. So in a hypothetical example, the 5 down to the 3.5, double that, like the 5 pound ground snow load reduced by 70% because it's heated and insulated would be 3.5 pounds. Double that, 7 pounds, but it's going to be a minimum of a 20 pound snow load. So if you're in a 60 pound snow load area, you reduce that, and then double it. These extension beams are going to be pretty big. It's just something to consider. So if you're going to do it big. But I'm not going to talk you out of it if that's what you want, because, you should get what you want. What I'm going to do here is just copy that first one because that's really tedious putting all that information back in there. And I'm going to go and just tell it that I'm putting this one on the back sidewall. All right, so now we've got our 1 foot overhang around the whole perimeter of the building. I'm going to go down and add the patio. This is going to be a canopy extension. So this is going to actually have a beam sticking out off of the main column. That's why I ran the bay spacings to line up with the patio area. That way we're going to have an extension beam here, probably one here, here, and here. And that's what's actually supporting the patio below the eave height. So we've got a canopy extension. And let me just make sure I know which wall we're on. All right, so we'll do the end wall first, which is going to be above those windows we put in first. So it's going to be bay 1 through 3. Now we're extending it out 9 foot because this is a 9 foot canopy. We can't do anything. I'm not going to say we can't. We're not going to do anything longer than 10 to 12 feet on a extension beam. You would have to get into more of like a lean-to. So if you're trying to save money and you don't want to have the column supports for a lean-to, try to keep your patio, your overhang under 10 to 12 feet depending on where you're at. So this is 9 foot out. We're going to run this at 10 foot at just a 1/12 pitch, which means that the roof line is going to drop 1 inch for every 12 inches it comes out, or 1 foot for every 12 feet that it comes out. What we got going on here? So we're not worrying about that. So basically, again, I'm just calling out the extension beam being a rolled beam, and the girts, or I'm sorry, the purlins in the roof, which are galvanized. We don't do red primer. That's something in another video, you know, I'm going to go over the quality of product that we're offering as opposed to what everybody else does out there. So like all the purlins that are sitting on top of that canopy extension are going to be hot dip galvanized, which is a protective coating that prevents the steel from rusting and corroding. Most companies are just going to put a red primer on it, which, you know, ideally should be painted. All right, so I did that one. I'm basically going to just copy this one again to prevent the tedious work of doing it again and again. I'm going to go over here and make this a back sidewall. This would actually be running from bay 2 to 4. We're going to extend it out 9 foot on this side and we move that 9 feet up. Actually did it backwards, so we need to extend it there, get rid of that. All right, so that's basically connecting this overhang to this overhang. 2 to 4, 9 foot, and everything else should be there. That's that OCD right there. All right, and then we're going to do the last one, which is going to be the front sidewall. But what I want to do is copy this. Then it's going to be the front sidewall. Bay 1 to 3. And then we need to add the 9 foot extension to the left to connect those two and get rid of this one. So that's all of the extensions. That's it. There it is right there. Now, it may look a little goofy here with the extensions the way that they are, but that's something we're going to actually manually go in and provide the corners to connect. It's just how we have to enter it into the program. So we did the design, we got the bracing in there, we have the loading for the location, we have the extensions. There's no gutters. we pretty much did everything that we need to do to make this, to manifest this building. It's telling me that I need to bump the load up on one of the frames. It's probably going to be this one, and it's probably because we added that canopy extension. So 14.0833. And then I actually have to go in here and roll these end walls, which is something we can go over in another video. These are the end wall columns on the end. I'm taking them to a rolled column because it's going to have to support the canopy beams. You know, obviously you don't want to have a C channel back there as an end wall. Even though we made the rigid frames as opposed to the post and beam end wall, like we talked about in the earlier part of the video, the end wall columns are still going to be C channels. In this case, I got to roll them because they're going to support the weight of that canopy extension. Just to kind of elaborate and let you know what I'm talking about here, so you understand it. We don't have to do it on the other side because there's no extensions, and we don't need to push the costs up anymore. I think we're pretty good here. One thing I want to do is go in and paint the roof. Put a painted roof on this bad boy. All right, so that's it. We already know. It's just basically telling me that we have to double the loads. So let's make it. That's it. Now I already ran this once, and again, like I said, I recorded it, but my mic wasn't working. I was pretty upset, but I had to come back to the table and release this video because I love to design a house for you. I love to see it after you bought it from us and put it up. And honestly, I've got some pretty good knowledge and expertise in the industry to be able to, assist you throughout the process. So what we're providing, though, just before we, while this is running, is we're basically providing the main supports, the exterior walls, the roof, and all this. It's going to be a clear open space in here. All of this is up to you. You could buy the same building, and these windows, we're not going to have them located. You could rearrange the window openings. You could rearrange this layout to fit your vision. So just keep that in mind. All I need is a width, a length, a height. What do you want to do on the roof pitch? Do you want to do extensions? You see what's going on here. And we'll make it happen. Let's manifest it like Monopoly in real life, But you're raising your family in this building. So it's almost done here, and I'm going to show you what that would basically just say if there's any warnings that we would need to address in the design. The computer's pretty smart. I mean, actually, the computer does most of the work. It designs everything. Once we would reach an agreement on the price, you would put down a deposit. The deposit would release the 3 sets of permit drawings so you could pull your permits. And then we actually take that and send it to an engineer to do his review. Prior to you getting the drawings, he's going to review it, sign off on it, stamp it, and then we send it to detailing. And they do their part. We design everything, and then we fabricate it and ship it to the site. So you can see the dimensions on this. It's a 39 by 90, 14 foot tall with a 612 roof pitch. Here's all the codes. The wind exposure, it's an enclosed building, but we're not going to get into the price because it depends on where you're putting it. And we also have to add freight because we're going to put it on a Mack truck and ship it to the location where you would have to unload the various packages that come. And none of those weigh more than 3,000 pounds. So you would need like a forklift or a scissor lift to, unload the building. But back to what we're doing here. Here's what our finished product's going to look like. let's go over the rigid frames. These are the main supports, and we've got three different ones here because we have the smaller ones on the end wall that we swapped out for your typical post and beam. We've got the two intermediary ones, which are 2 and 4, and then we've got that center one that we reduced, just to pick up a couple bucks, save the customer a couple dollars. Hang on here, gotta get my smoke. So basically all I'm doing is taking the output or the input from what the computer generated, and we're gonna print it out over here. I'm gonna basically go over a couple things with you and conclude this video. All right, so let's see if we're close here. That's what we're looking at, right? Here's what we designed. The only thing I'm going to say is the roof pitch might not be precise, but I think it's pretty close. So that's it right there. The main columns that I'm going to show you are going to be here. This will be the RF1, this will be the RF2, this will be the RF3, RF2, RF1. I tried to rotate this. I'm really horrible at this, but let's see. I like to think I got a steady hand, but this rotate is pretty rough. So there's the garage doors. I don't know how we swung around to the back side of the building so quick. And then here, if I could keep it steady, there would be the front, the overhang. So that's what we did pretty quickly too. So let's get out of here because I don't know, I can't maneuver that very well. So this is going to be the first beam that we were talking about on the end walls. This is what I swapped the post and beam out for the rigid frames. So you've got a column here. That's your main support column. That's your main rafter. These are purlins. They're Z purlins. They're galvanized. They sit on top of the rafter, and the sheeting is going to attach to those via the stainless steel fasteners that we provide. There's mastic in between the laps on the panels. And now this is your column again. These are girts. They're the same as your purlins. They may be 8-inch, 10-inch. They're going to be galvanized, but they're called girts when they're in the sidewall, and they're called purlins when they're in the roof. So these ones are 8 inches, and then you got a 1/4 inch for the high profile on the panel. These are the canopy extension beams that I was talking about earlier. We're not going to do more than 10 to 12 feet on those. You can see how it's just a beam projecting right off the outside of the column. It's going to save you a couple dollars because you're not going to have another column coming down here that you're going to have to put a pier in the ground to support. So that's why if you could keep it under that, a lot of people are like, oh yeah, I want to lean to on the side so I can pull my camper in there or my trailer. And they're talking like 20, 25 feet. If you don't need 20, 25 feet, let's keep it simple with 10 to 12 feet. Squeeze it under there and save yourself some money and concrete. So this beam right here is going to be located here on this end wall and this end wall, right? So this RF2 is going to be this one and this one, which I'm going to show you now. So this is showing you the clearance that you're going to have from the inside of that column to the inside of the column. The column width's about 11.5 inches. It's your column, girt, eave extension, or canopy extension. Here's your eave extension of 1 foot that we put on there. And you can see how it's just basically extending that out. And then you're going to have 21 and 11, 13, 16ths of an inch clearance up to here. So this is wide open area that you could make whatever. Now I'm going to show you that middle rigid frame where we at like 11 inches. So this one's 10.5 inches. You see how, if you remember earlier in the video, I broke out that third column line and I actually reduced it because it was only carrying 20 pounds on either side of it. That made the beam only have to be 10.5 inches. So it saved us. It's definitely going to save you a little bit of money, you know? Like, I know what I'm talking about here, my guy. That's all I'm saying. So that would be your middle one. You got your interior clearance. And basically these are the column, the rafter. That's it. So let's go into one more. That's going to be the main columns that support the whole structure. And then inside you do however you want. I'm going to show you what the anchor bolt. Whenever you buy a building, you're going to get your permit drawings, and included in it is going to be this anchor bolt layout. So this is that RF1, which is designated a C. A C. See how the C's are over here? And then that rigid frame 2 is going to be a D. So it's designated D on the anchor bolt layout. And then this is also a D. So I guess it's just, at the end of the day, it made them all the same size at the flange on the bottom. That's pretty cool. Even though they're different sizes is what I'm saying. So these are all your openings. You see how they're field located. So there's no anchor bolt or epoxy bolt holes shown, because you're not going to need them, because they're not jammed to the ground. They're just going to be jammed between girt to girt. But on these overhead door openings, you're going to have to put some epoxy bolts down or anchor bolts to support that jam for that overhead door. So these, your end wall, just like you would for your main columns. So if you're not familiar, you have to have a pier, a frost wall, or a full slab underneath the building. At those piers, these locations here, you're going to have J bolts dropped into that when the concrete's poured, that the bottom of our beam is going to bolt to. And I'm going to show you how you determine, the diameter of that hole and the location. But that's what's anchoring the building to the ground. So we could get into that into another video, but just so you're aware, like, that's because a lot of people are wondering about, comparing it to wood construction. But I mean, we're anchoring this to the ground via concrete pier or your slab. So you're going to have 4 bolts sitting in your slab that the bottom of the I-beam is going to bolt down to and be held to the concrete with. Now on your overhead door openings, it's only 2, because it's not a main support structure. But you'll actually see up here on this drawing, it'll show the diameter of those holes. I could just zoom out. Yeah, so we got up here on the right, these circles for the end wall columns are 5/8 of diameter, and then the main support ones are 3/4 of an inch diameter. Now I'm going to show you one more thing, which is going to be that flange at the bottom. You're going to get, this is showing you that A, the B, and the D that we were just talking about. I don't know why I can't zoom in here. So A, here's what the bottom of that beam is going to look like that's actually bolting to your concrete. You got 5/8 diameter holes. It's 8 inches depth, 8 inches wide. This is the B, which is an end wall column for the overhead door openings. It's just a C channel. And then your main support columns C and D. They're 8 inches wide. They're both 10.5 inches long. Same bolt diameter, 3/4 of an inch. So you got an anchor bolt here, here, and here. So if you have any questions, drop a comment and ask me, and I'll reply, and I'd love to help you out. At least help you understand how they're engineered. If you're an architect, get with me, because I'd hate to see you over design somebody's plan and put them into a structural steel situation where they could just get a prefab building knocked out pretty quick. What's the turnaround time? If you buy one right now, you'll get your engineered stamp drawings in 3 weeks, 4 weeks possibly. And it could be a little quicker, but I'm just going to tell you worst case scenario, so you're not upset with me if they come on time, right? Or if they come earlier, then you're going to be happy. And then the building, as of the date of this recording, which is July 30th, it was the 29th. We now rolled into the 30th. We're looking at like October delivery, possibly September, but I'd rather tell you October delivery. So if you want to build a house, this year, get with me quick. Let's take some time together and let's make it happen. Thanks for watching. If this was helpful, if it was worthwhile, like, subscribe, because I plan on doing some other projects as far as warehouses, aircraft hangars, just to show you the possibilities of what we could do. And if you need a building, call me, 412-444-0575. My name is George. It's Olympia Steel Buildings. If you search, you can find my cell phone number and just shoot me a text. Thanks for watching. Let's build.